हेलो बच्चों, let's read this question. A parallel plate capacitor of capacitance C remains connected across a supply voltage of V volts. Now, a dielectric slab of constant K completely fills the space between the two plates. Then we have to find what will be the new capacitance and energy stored in the capacitor. क्वेश्चन में हमें एक पैरेलल प्लेट कैपेसिटर दिया गया, इसकी कैपेसिटेंस C है and it is connected across a constant potential difference source, let's say V, और इसकी कैपेसिटेंस है C. नाउ कैपेसिटर के प्लेट्स के अक्रॉस हम एक डाइलेक्ट्रिक इंट्रोड्यूस करते हैं जो इसके स्पेस को कंप्लीटली फिल कर रहा है सच दैट इसका डाइलेक्ट्रिक कांस्टेंट K बताना है. व्हाट विल बी द न्यू कैपेसिटेंस C and new energy stored in the capacitor. For that, please note the key concept of this question, which says that the dielectric constant of a medium is defined as the ratio of permittivity of that medium to the ratio to the permittivity of space. So we can write the value of K as, let's say, permittivity of this dielectric as E and permittivity of space is E naught. So we can write the permittivity of this medium as K into epsilon naught. Now, capacitance initially when there was no dielectric, this is defined as A into epsilon naught upon D, where D is the separation between plates, A is the area of cross section of this this parallel plate capacitor, and epsilon naught is the permittivity of space. Now this dielectric is introduced. This was C naught. Now when dielectric was introduced, we can write capacitance as A into epsilon upon D, where epsilon represents permittivity of dielectric. Now we can write E as K into epsilon naught upon D. Now this whole expression is defined as C naught into K. So we can see that the capacitance after introduction of dielectric, this is becoming K times the initial capacitance. Now let's see option B, which is energy stored in capacitor. Now energy initially stored in capacitor, this is defined as half into capacitance C into potential difference applied across this capacitance. This is V square. Now this is E naught. Now what happens when the dielectric is introduced? We have seen earlier that its capacitance become K times C. Moreover, the potential difference across this parallel plate capacitor will remain same as V, which is supplied by this vector. So we can write E nu, this is half C dash into V square, and we can substitute the value of C dash, that is K times C into V square, and this is half C V square into K, and this is K into E naught. So we can see that the energy it can store is K times E naught, and its capacitance became K times C naught. So this is K times, capacitance is K times, and energy also becomes K times. So I hope आपको ये concept समझ आया students. Thank you.